You're going to need your calculators. And here we go. Oh yeah, no, I know all the little tricks. You guys are professional distractors. Keep asking questions. I don't know if you guys were thinking that or not, but I know all the little tricks. All right. LOL. All right. All right, guys. Focus, 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 focus. All right. So don't worry about this. We eventually will get there, probably Monday when we see each other again. So all this time, what we've been doing, you guys have been focusing on arc cosine. And here it is. That's a plus minus, right? The inverse cosine. There is others. Here are the formulas that you're going to be using. There's this one. Well, primarily because that's the one in radians. And there is this one. Arctan is the only one that just has one equation. Sine and cosine, when you do the inverse of it, you're going to have two expressions. So here's equation 1. Here's equation 2. Chav, why is there a pi in equation 2? Well, we'll talk about that. Chav, arc cosine just has one equation. No, that plus minus is like one of them's a positive and the second one's a negative. Does that make sense? And I know we practice a little bit. This is what we have practice on. So we've already done that one. We'll still bring it back. All right. Yeah, and don't freak out. You guys will probably always have a calculator in hand. So more than likely, you probably won't have to do the algebraic manipulation. You can just graph it and see on your graphing calculator where it happens. But I would really like for you to know how to solve it algebraically. Does that make sense? Okay. Now, of course, I don't want to be a teacher that just tells you, here's the formulas, just use them. I want you to know where they come from. So that's why I left some blank space right here. And so let's chat about where these formulas come from. I'm going to draw a unit circle on the left-hand side. I'm going to do 2 unit circles, but I'm going to draw one right here like that. And I know that whence you guys have been doing like finding angles with whence. It's the same thing, but we're in radians. So if I tell you, let's do a simple one. If I tell you that sine theta equals 1/2, I want to know in radians, I guess you could also tell me in degrees, I want to know where this happens. Luckily for you guys have been doing unit circle quizzes, and you know that this happens here and here. That angle there will give me that 1/2 because that coordinate is square root of 3 over 2 comma half. And this angle here, which is actually this angle, and I'll call it theta 2 here, that will give us negative square root of 3 over 2 comma half as well. Later on, when you do delta math, remember that I told you that sine was equal to y. This is like saying y equals 1/2. So if I were to draw a horizontal line at half, check it out. That green line there is y equals 1/2. Is this all making sense? If I were to tell you cosine equals something, then you would draw me a vertical line of where that happens, right? You'll see what I mean when we do the delta. All right. No matter how hard you try on the calculator, if I go theta equals arc sine, if I just type this in the calculator, no matter how hard I try, the calculator will either tell me 30 degrees or pi over 6 if you're in radians, if you have a CAS. No matter how hard you try. But I know there's another one at 150. So look, here's my calculator. And let me reset it. 712. All right, check it out. Arc sine, I'm in radian mode, 0.5. Boom, that's pi over 6. Chav, I don't believe you. Okay, look, pi over 6. See, that's pi over 6. If I go to a degree mode, it's going to just tell me 30 degrees. I don't know if you guys want to see that, but since you guys have physics, I'll show you guys. See, 30. It is, I don't want to go against anyone, but these are just ratios. So the unit circle is always involved in this, but you don't need to reference a unit circle. You can just use your calculator. All right. What was I going? Okay. No matter how hard I try, the calculator is not going to give me the other answer. It's not. So how do I get the other answer? Chav, what are you talking about? How do I get theta 2 like this? See how this right here, the one that I'm circling in red, you guys told me that was 30 degrees or that was pi over 6. That calculator is always going to spit that out. Well, notice this reference angle right here, I'm going to call it theta r, that is also 30 degrees or pi over 6. So how do I get theta 2? Well, I can get theta 2 by doing pi, if I'm in radians, minus arc sine of half, or I'm going to say in radians, right? In rad. If I'm in degrees, I can go 180 minus arc sine of half. Do you guys see that? So that will just be minus 30, and you'll get that 150. 150. Sorry that I said it that way. All right. So guys, why am I telling you this? I don't want you to be a robot. I don't want to be a teacher that just says, use your formulas. Look, that's where the pi came from. That's where this pi came from. Oh, what about if you're degrees? That's where this 180 came from. Because the calculator will never give you the 151. But if I put 180 minus your arc sine of 30, or arc sine of half, which is 30 degrees, you'll get your 150. Do you guys see what's happening? Okay, so don't worry. In a little bit, like I told you a little while ago, if you don't want to do it algebraically, you can just use the calculator and see where they intersect and all that good stuff, and you don't have to worry about algebraic manipulation. All right, so let's use our skills of what we just... Oh, you know what? One more. Because I did say I was going to do 2 unit circles. So I'm going to change my color to purple. You don't have to. If I were to tell you where is cosine of what angle equals... let's do the 1/2 again. Cosine of angle equals a half. So here is my unit circle. And here's a half. Bam. There's my x equals half. So that it's that point and this point. So what are the angles? Bam. Bam. So I want this angle, theta. And I want this angle, theta 2. So notice, remember that cosine can be replaced with an x. So it's like cosine is your x value, right? So this is like saying x equals a half. So I want you guys to notice that I just have a horizontal line. That's what you're going to have to do in a little bit. You'll see in a little bit what I'm talking about. So the calculator, again, will never give you that 60 it won't give you the second one. So that's why we do all the time. Like, I know that theta has to be 60 degrees, right? And then what's the other one? 300 degrees? The calculator, no matter how hard you try, will never give you the 300 degrees. Look. I'm in degree mode. Arc cosine of 0.5. It's always, no matter how hard you try, it's always going to give you 60. No matter what. It'll never give you the 300. Child, what if I do a revolution? Will it give me the 300? No. It'll just give you another coterminal angle to the 60 degrees, the 420. So how do I get the 300 degrees? Well, that's where the plus minus comes in. See that plus minus in front of the cosine or the arc cosine? If I go, I'm going to write theta 2. Negative 60 plus 360, do a revolution, that one will give you, check it out, that one will give you 300, which is this angle, theta 2. Do you see how it works? Like, do you see why the plus minus, guys? Or no? Tell me, Uncle said, no, real talk, tell me.
I'm just like, there's a lot going on.
Yeah, there is a lot. But what I'm trying to say is this. The calculator, no matter what, it will never give me theta 2. So that's why I put a plus minus in front of the arc cosine, because check it out. Look at this one in red. That's 60 degrees. And this, if I go counterclockwise, that's negative 60 degrees. What's up?
So can you see where the degree is on the angle? Just subtract that from 360.
No, okay, not like you're trying to do like what we did for arc sine. The best route, I think, is to do plus minus. Because check it out. If I go from you always start there, right? This is always my reference. If I go counterclockwise, that's 60 degrees. If I go 60 degrees. If I go clockwise, that's negative 60 degrees. So that's why there's a plus minus. Do you see that? So, but you might be onto something. Let me see. You might be onto something. But the best route is just put plus minus, arc cosine. Now, do you have to do it? No. If it's a perfect coordinate, you don't have to do it. Like, you can just use your radians of that perfect coordinate. You know what I mean? So we'll do some examples. Don't worry, we're gonna do some examples, and I'll show you an alternate way. All right, let's go to this one, guys. Don't worry, I'm gonna go slow. Solve the equation 10 sine x minus 2 equals negative 3 algebraically in the domain 0 to 4 pi. So you only have to do this if I ask algebraically. If you don't see this letter, do you have to do it algebraically? This letter, this word. No, you can just type it in the calculator. Type this into y1, type this into y2, and see where they intersect. But right now, I'm asking algebraically, so because I want you to know, I want you to see it. So here we go. I'm going to first start out by writing the statement. 10 sine x minus 0.2 equals negative 3. I'm trying to solve for x. What's my first move? Divide by 10. Awesome. Sine x minus 0.2 equals negative 3/10. What's my second move? No, don't say the word multiply by arc sine. Just say take arc sine, right? I hope they don't say that in physics, right? Multiply by arc sine. They just say take arc sine. Okay. You take the inverse of sine. So x minus 0.2 equals arc sine of negative 3/10. And I'm going to write plus 2 pi n because sine repeats every 2 pi. Are we okay? What do you guys think? Are we okay? We haven't done anything crazy. Yeah, the only way to get rid of this sign here is to do the inverse sign, right? Okay, because it's sine of this argument. So whatever you do to one side, you do to the other. So there it is. So arc sine of negative 3/10. We're okay so far, guys? All right. I'm going to take my calculator. I'm going to move this 0.2 to the right. I'm going to write x equals 0.2 plus arc sine of negative 3/10 plus 2 pi n. And this part right here, I'm going to put in my calculator. X equals, and I take my calculator. Make sure you're in radian mode. So I'm going to take my calculator. I'm going to go to mode. I'm going to go to radian. And I'm going to clear this. Let's see, where was it? 0.2. So I'm going to go 0.2 plus arc sine of negative 3/10. And I got negative 0.10469. Is that what you got? Negative 0.10469. I'm actually impressed I was able to memorize those numbers because usually I don't. And I didn't get good sleep. I think it's a coffee because it has like 350 milligrams of caffeine. That one at least. It's the XL cold brew. Okay, I'll stop. All right. This will only give me half the answers. It's only going to give me half the answers. How do I get the other half? That's equation number 2, right? So see? So how do I get the other half? By doing this. Here's what I just did. Equation number 1. I did this guy. I have to do this. Pi minus arc sine. Do you guys see that? So I'm going to start right. I'm going to put a bullet on that one. Not on that one. I'm going to put a bullet on this one. I'm going to start right there. X minus 0.2. I guess you can put x2 in the bottom. X subscript 2 equals pi minus arc sine of negative 3/10 plus 2 pi n. Trying really hard to not give you too much information, guys. Okay, that sounded so bad. I don't want to overwhelm you. I'm trying to tell you to use logic. Remember that arc sine is your y value on the unit circle. So this is only going to give me one answer. This is like, where is the sine? Sine theta equals negative 0.3. So either quadrant 3 or quadrant 4. The way I have it right now, it's only giving me half the angles, half of the total angles, right? Because there's 2 answers. You're in quadrant 3 or quadrant 4. So this is what I'm trying really hard not to confuse you guys. All right, I'm just doing equation number 2 to get the other half of the answers. I'm going to move that 0.2 to the right. X2 equals 0.2 plus pi minus arc sine of negative 3/10 plus 2 pi n. And I'm going to put this in the calculator. I'm going to go 0.2. Don't worry, I'm coming back. Plus pi minus, and I guess I could have just scrolled up, right? But, oh well. Arc sine of negative 3/10. Enter. So there it is, 3.646285. 3.x2. 3. I already forgot it. See, one I would remember, one I forgot. 646285. 646285 plus 2 pi n. How do we feel? Okay, I'm going to go back to red. Here are my answers. X equals, I'm only looking between what and what? 0 and 4 pi. This is not an answer in that domain. So this is my first one. 3.646285, comma. The second one is going to come from the one in red when I add 2 pi to it. I guess I'll call that x1. So I'm going to get my calculator. I'm going to scroll to the negative 0.1. And I'm going to push enter plus 2 pi. That's my second one. 6.17849. 6.17849, comma. Yes. Oh, I'm about to get my third one. The third one comes from x2 at 2 pi. So I'm going to go to 3.64, just like Bernal Sierra told me. I'm going to go plus 2 pi. Look at you guys being nerds. I mean that with love. YouTube, I mean that with love. Don't hate me. Okay. 9.92947. 9.92947. If you guys don't like when I call you guys nerds, let me know and I'll stop. Which I hope, I'm not being a bully, I promise. What's up, Woody?
I have a question.
Yeah.
You said that you didn't use the negative 0.174. You didn't use that one because it wasn't in the domain.
Yes. Yeah, I want, see how it says here in the domain 0 to 4 pi? I want answers between 0 and 4 pi, and we're still not done. We still got more answers. That negative 0.104 is to the left of 0. Okay, now to get my next answer, take the 6.17849 and add 2 pi. So I'm going to scroll up. Plus 2 pi. 12.4616, and I believe that's the last one. 12.4616. If I try to take that 9.92 and add another 2 pi, oh, it says it's Friday. I was like, what the heck is going on? It would be outside the domain. Chav, I don't know how you can tell. Well, because 2 pi plus 2 pi is 4 pi. If you take a positive number, you're already to the right of 0. And if you add 4 pi, well, you're outside the domain of 0 to 4 pi. But this one's negative to the left. So if I add 4 pi, I'm going to be inside between 0 and 4 pi because it's pretty close to 0, but not quite. What's up, Uncle Says?
How do we get the 12.461? We added.
I added 2 pi to this number right here. I guess you could also say added 4 pi to the negative 0.140469. All right, what's up? Yeah. You can always I don't know how far I gotta go. So good job, Pantoja. I didn't mean to call you Pantoja. Sorry, Miss Puente. Both of you start with letter P, so it just boop. It's weird how memory works. There it is, 12.566. So as long as I'm below this number, you're good. All right. Now it says verify the solutions graphically. Okay, guys, I probably on the exam will just tell you just to give me the x values. So a lot of you, maybe you're like, man, I don't want to do all that. Then just do this. What was the equation? 10 sine, okay. 10 sine x minus 0.2. So try it out, guys. Try it out. Practice. And on y2, what am I going to type? Negative 3. And then look. Okay, so does everyone have this on y1 and y2? Okay. Click on window. Don't push graph yet. You're only checking your answers between what and what? 0 and 4 pi. See? 4 pi. And then you can leave the y min, y max like that because the magnitude is 10 for that sinusoidal. And I'll push graph, and I better only see 4 intersections. And look, 1, 2, 3, 4. Oh, did I do it right? Yeah, I did. And I bet you those are the answers. So let's see. Second, calculate number 5. Enter, enter, enter. Guess. Go to the one you want first. Let's see. Enter. 3.6462. Is that one of my answers? Yes. Second, calculate number 5. Enter, enter. I'm going to scroll to the second one. Enter. 6.1784. Is that one of my answers? Make sure it says the word intersection. Second, calculate number 5 again. Enter, enter. Scroll to the one you want. And push enter. Let's see. 9.9294. Is that another answer? Yes. Last one. Second, calculate number 5. Enter, enter. Scroll. Enter. 12.4616. Is that another answer? There it is. Do you see how we're doing it, guys? Yes. When you click on window, I just clicked the domain. See, between 0 and 4 pi. So because that's what they want. See how it says? Let me click on my little laser that I paid a lot for. You see that 0 to 4 pi right here? So that's 0 to 4 pi. Sorry, guys. I wasn't trying to be funny, but okay. Anyways, so that's 0 to 4 pi. That's what I'm going to put for x min and x max because I just want my solutions between those x values. And then everything else I just left alone. Negative 10, 10. My magnitude was 10 for the sinusoid. So I left it as negative 10 and 10. Okay, good job. All right. Yeah, hit me. What's up? Oh, did you have a question?
No, she was just asking about the first one.
Got it. All right, guys. There it is. All right, so we're going to do one more. This one's in degrees. So let me change my calculator to degree mode. Does everyone know how to change back and forth? Okay. When you're in physics, I believe in physics, because you're working with, in physics there also is radians, but you're going to be working with degrees for the most part. So change your calculator to degree mode in physics. All right. Solve the equation. So I have this equation here, 4 tan x equals negative 5. And I know we don't have a lot of experience with tan, but real quick, before I get started, why does tan only have one equation and not two like the others? So this is a side note, guys. This is a prerequisite skill. So let's say I told you tan theta equals 1. There are two locations on the unit circle where tan is 1. I'm just doing a side note, guys. If that happens here, square root of 2 over 2, comma, square root of 2 over 2, and here. And since we're in degree modes, I'll go ahead and use degrees. That's 45 degrees. What's this one? That one's 225 degrees. Because you get negative square root of 2 over 2, negative square root of 2 over 2. Cool or not cool? No matter how hard I try, when I go theta equals arctan of 1, no matter how hard I try, the calculator is only going to give me the 45 degree one. But here's what I want you to notice. Do you see a linear line? Look at that blue line. Is the distance from here to here, is that 180 degrees? Yeah, so that is why tan, the arctan, because the period is 180. This is why tan just has one formula. See, if it's in radians, pi n. If it's in degrees, plus 180 n. And you just need one. You'll get both answers. See, no matter how hard you try. Look, if I take my calculator, let me clear it. Clear. Arctan, I'm already in degree mode. Arctan of 1. I'm just going to get the 45. And no matter how many times you do arctan of 1, it's always going to give you 45. How do I get the other one? Just go plus 180. Plus 180. And voila, 225. And sure enough, tan of 225 is 1. See? So hopefully you guys are seeing that these formulas come from somewhere. They just are just not magically done. And another demerit. That's another. Okay, I'll stop. Another demerit. Another yawn. And I need to stop that. Okay. You all right? Okay. Yeah. Let the record show that no one is safe. No. That was a joke. I promise. All right. Here we go. Let's go back to this. I'm trying to solve for x. The first three positive values. What's my first move? Divided by what? Perfect. Divide by 4. Perfect. Done. We're almost there. I want to get x by itself. What's my second move? No, don't say the word reciprocal. Arc. Say the word inverse. Arctan. X equals arctan of negative 5/4. And because I'm in degree mode, plus 180 degree n. Yeah, it's not, reciprocal and inverses are not the same, unless you're talking about numbers, but reciprocal and inverses for functions are not the same. Make sure we are aware of that. Are we still cool? I take my calculator, and I'm going to go second arctan of negative 5/4. And I close a little degree, boom. So this is what negative 51.340, that is a degree. Negative, so I'm going to say x equals negative 51 point, and I already forgot it. 347?
3401.
3401. 3401 degrees plus 180 degree n. This is what you call a general equation. Why is it called a general equation? Because this one will give me all the answers, all of them. I'm not asking for a restricted domain. It tells me what? The first what? First three positive values. Is negative 51.3401 a positive value? No. So I take my calculator and I'm going to go plus 180. And there's my first one, 128.6598. 128.6598. 128.65998 degrees, comma. Then I take my calculator again. Here's what's beautiful about the calculator, guys. Look at how beautiful this is. You don't have to type this again. You just push enter, and it executes the last line. It's like if you're doing code here, right? Look, you just push enter. Bam. Oh, look at that. This is why I think you can be so fast with this. So if you're taking SAT, ACT, man, grab one of these calculators because you can be so fast. 308.65. I feel like I'm a salesman for TI or something. 308.6598 degrees. Close. I want one more. Just take your calculator and just push enter. Super speed. 488.6598. 488.6598. There it is. Done. Yes. General equations apply for all of them. You can get a general equation. On this one, my general equation was that you have two of them. See, you have this one here and this one here. Those are my general equations. Okay, that was only the second one. Don't worry, I got you. So like, see how on this one it wanted answers between 0 and 4 pi? I would still grab a general equation so I can use those to get my answers between 0 and 4 pi. On this one, I wanted my general equation so I can find the first three positive. See? So it just depends on the context and like what you're given. On Monday, when we see each other again, you're going to be doing the same thing, but for real life problems. Like when's high tide? When's low tide? How often is high tide? How many sunspots are there this year? How many sunspots next year? It's going to be really good. You're going to see. Alcocer, what was the question?
So we just keep adding the 180
to the negative 51.304. So n is just an integer, remember? So I added 180 to this and I got this number. And then I added 180 and I got the next one. Yeah, what's up?
So we're going to figure out if we need one or two general equations based on the context, but I thought it would be like based on like which of the sine and cosine because like sine and cosine have two equations.
Sine and cosine have two equations and 10 only has one.
But so does that mean every time you're using sine or cosine you're going to have two general equations?
Almost always, except for like the situation where you have something like sine theta equals 1. There's only one location on the unit circle that has a 1. So, but you could, if you wanted to, you could do equation 1, arc sine of 1 plus 2 pi n. That's pi over 2. And if you wanted to do equation 2, you're going to get the same answer. Pi minus arc sine of 1. Well, pi minus pi over 2 is pi over 2. So it's like you're getting the same equation again. You see what I mean? So there's special rules here and there. But yeah. Okay. All right, guys. I'm a little scared, but I think we're tough, and I think we can do this right here. You guys ready? All right. So if you had a hard time in algebra, it's possible you're going to have a hard time with these. So I need your A game for this, guys. So it says in degrees, solve algebraically sine squared x minus sine x minus 2 equals 0 between negative 90 and 270. Okay. When you were in algebra, you had a question very similar. I'm going to write the word similar. And your question was this: x squared minus x minus 2 equals 0. In algebra, how did you solve that question? You could factor. You could also use a quadratic formula. Yeah, I think for this one, factoring is the best route. So what two numbers, when you multiply, give you negative 2, but adds up to a negative 1? I think there's only one set. If they're integers. What two numbers, when you multiply, give you negative 2, but adds up to a negative 1? Negative 2 and 1. X minus 2, x plus 1. Yeah, see, that's why if you know you have issues with factoring, guys, come in and we'll give you a whole dosage of factoring. So here we go. What makes this statement true? Well, if x is -1, -1 plus 1 is 0. 0 times anything is 0, so that makes it true. Or if x equals 2, 2 minus 2 is 0. 0 times anything is 0. So when you were in algebra, you told Ms. Gonzalez that the answers were 2 and -1, and Ms. Gonzalez probably went, you are right. Probably. I don't know. I can't do a good impression from her. So there it is. Now, how does it work for pre-cal? The same. So just like you found factors, well, here are my factors for this. You're going to go sine x minus 2, sine x plus 1. See? It's the same. So the only way this will be 0 is if this expression is 0. So that means sine x has to equal 2. We'll talk about that in a little bit. Or if sine x plus 1 is 0. So whenever sine x is -1. Side note, what's up? What do you mean? Oh, that it's similar to this one. So see how I have x plus 1? Yeah, so instead of writing x plus 1, since they're similar, I can write sine x plus 1. So I just replace the x with a sine x. You know what I mean? Good question, miss. Good question. Keep asking. All right. A side note. The biggest, remember, because sine x, depending on the context, if you're in a unit circle or if you're in a right triangle, the biggest sine x can be, or if you're looking at the graph, see, there's so many ways to look at it. The biggest sine x can be is what? What's the biggest sine x can be? The biggest value. What's this value up here? Way up here. The y value. Not 2. Yeah, what's the maximum value? It's not 2. The sine x curve, guys. If I were to tell you y equals sine x, what's my max? 1. The biggest sine x can be is 1. The smallest sine x can be is, no, not 0, it can be smaller, -1. See, you just got to think a little bit, guys. Try really hard not to go through the motions in this class, because that will get you eventually. So that means sine x equals 2 will never happen. If you try to tell the calculator, if you try to go arc sine of 2, your calculator will tell you error. Don't believe me? Look. Let's try it. Second arc sine of 2. Error. You can't do it. No se puede. No se puede. I'm trying to speak Spanish so I can, be fluent in it. Because at one time I was. So I'm trying to talk a little more. All right, but this one is possible. Look, check it out, guys. Because this is a perfect coordinate, you don't even need formulas. This is why we talk about the unit circle so much. Where on the unit circle is sine x -1? Remember, sine's a y value. Way at the very bottom, down there. 270 degrees. Perfect. I come up and I look. Oh, look at this. Is 270 degrees a possible answer? No, be careful. Look what it has. It has a... If it has a parenthesis, that means you cannot include 270. But notice there's a bracket at the -90. If I go like this, is that -90? If I go clockwise, heck yeah, it is. So my answer is -90 degrees. Heck, even the calculator would have given you that. I know we haven't studied inverse when it comes to like the domain of inverse functions, but check it out. Second arc sine of -1. I'm not fake. It better tell me -90 because I'm a teacher and I'm supposed to know about all these domains, right? So it better say -90. Look, check it out. It tells you -90. Unrehearsed. I just typed it in. It came out -90. I'm sure your other teachers can do the same because they're teachers and they're knowledgeable in their content. Okay. Here we go. Sometimes I'm tempted to like skip this question, but this will be the last one because I want to give you the best education possible. This one is harder, quote unquote, and maybe I shouldn't even say harder because maybe that makes your heart rate go faster when I say that. You can do this. You are smart. This is just like the last one, but notice I'm going to write similar. This is similar to 4x squared minus 2x minus 3 equals 0. This one is not factorable. And then why is it not factorable? That's an algebra 2 thing, but whatever, not a big deal. If you were to it's the AC method. If you were to multiply those, you're going to get 12x squared. And then you say, what two numbers multiply to give you 12x squared that add up to a negative 2? Nothing. There is no two numbers that multiply to give you a negative 12x squared that the difference is negative 2. At least not in the high school world. There is, if anything's possible, but we're not doing complex analysis or row analysis, or we're not talking about any of that. We'll wait for your professors to do that. Are we okay? So this is not factorable. So is there another way to solve when you were in algebra 2? I guess you can type it into the calculator and see where it crosses the x-axis as well. But let's do it algebraically. Is there another way? Start with the letter Q. Second letter U. Third letter A. Quadratic something. Quadratic what? Quadratic formula. AX squared plus BX plus C equals 0. And the quadratic formula is, do you know it by heart? Negative B plus minus. Yeah.
All right, Emma.
No, there's a song. You could also say like there's a negative boy and he was undecided about going to a radical party, and he was a square boy because he was negative. And all right, let's just, okay, no, don't all right, there it is. Quadratic formula. All right, guys, focus. So x equals, so let's see what my A is. A is 4, B is negative 2, C is negative 3. So x equals 2 plus minus square roots. And then I'm going to have negative 2 squared minus 4 times negative 3. Dang, I made it too close to this. There we go. All over 2 times 4. I'm going to do the positive one first. I'm going to call that x1. And then I'm going to do the negative one next. So I come to my calculator. And you guys check that I'm doing this correct. I'm going to push alpha y equals, enter. 2 plus square root. And I guess technically it's negative 2 squared, but you don't have to put the negative in the inside because I'm squaring it. Minus 4 times with a negative 3. And then all over 2 times 4, right? Yes. Yeah, you can just type in 8 if you're trying to be faster. And there's one answer. So I'm going to put 1.151387. 1.151387. Okay, and then I'm going to go back, and instead of the plus, I'm going to what? Minus. So you don't have to type it again, guys. Speed. You are speed. So you just change a plus to a minus, and voila. Negative 0.651387. Negative point, I already forgot. 651,387, like that. Okay. All right, perfect. Now that's what you would have done if you were in algebra. We're not in algebra. We're in pre-cal. Relax. We're halfway there, guys. So this can be written like this. So I'm going to rewrite it. So you know what? Maybe I should do it in a different color. Different colors to show the differences here. 4 sine squared x minus 2 sine x minus 3 equals 0. Now sometimes people forget that this sine x means this. That squared means this. So it's just like this guy. See? It's just like that. A sine x squared plus b sine x plus c equals 0. So that means sine x equals negative b plus minus square root b squared minus 4ac all over 2a. You don't have to write any of that, guys. I'm just trying to show you. So that means I can say sine x equals that, 1.151387, or sine x equals this, negative 0.651387. Now wait for you guys to catch up. You can't factor it, so you can't. Yeah, like do this. Don't worry, I'll come back. Like do this right here. Now, if it's factorable, you can do this.
No, the other one.
Well, we're about to take our sine. Yeah.
The quadratic formula?
Yeah, we did. We already used the quadratic formula. We got these answers. Yeah. Guys, I was really tempted to not do this because I do got to differentiate between AP and pre and regular and honors, but in my heart of hearts, I felt like I need to offer the best education I can, and I want to expose you, and I don't want anyone to have an upper hand. Like I don't want you to feel when you go to the university like, oh, I can't hang. So here we are hitting you with this because you can. Look, we're doing it right now. All right, check it out, guys. You don't need to write all the top stuff there. Plus, I have the video, so you can always, All right. Okay, we're good. Okay. All right. Almost. We're almost done. Don't worry. All right, guys. Remember this. Remember this right here that we just had a conversation on, right? So look, which one can I not be? The top one or the bottom one?
The bottom one.
You can't be larger than 1. Does that make sense? That one's 1.15. If you try to do arc sine of that, you're going to get an error message. But this one you can be. So I'm going to write it right here. I'm going to use some of this space because you don't need all that space here. So I'm going to go ahead and do this. X equals arc sine of negative 0.651387 plus 2 pi n. I'm going to take my calculator, and that's exactly what I'm going to do. Clear it. Oh, no, not clear it. Okay, good. It's still here. I thought I lost it. Second arc sine, and I'm just going to scroll up. Look, I'm just going to push enter on that. Boop. Enter. Oh, I'm in degree mode. I want radians. If I were in degree... No, they have. The last two were degrees, remember? How did I know that was degree really quick? Because it gave me negative 40. It's a really, really big number. Without a question, you're like, how'd you know you were in degree mode? Plus, in the top, it told me probably degree. But there it is. Enter. And now look at the difference in numbers. See, I was expecting some little number, and I got some quote-unquote big. And I guess it depends on the person what big is, but the 40 is way bigger than the 0.7. Because when you're in radians, you're talking about like between 0 and 2 pi, or between negative 2 pi and 2 pi. Okay, so negative 0.70941. So here we go. Negative, so x equals negative point, I already forgot it. What was it? 70941. 70941. Make sure you guys are trying on your calculators as well. That's my general equation. There's another one. Well, yeah, remember, miss, every sine and cosine have two equations. This is only going to give me half the answers. What's the other one? Pi minus arc sine of this die. Negative 0.651387 plus 2 pi n. I'm going to put this in the calculator. I just go pi minus, and I guess I could just type in that number, but I like to have this like that. See? Oh. Enter. So there it is, 3.85100. 3.85100 plus 2 pi n. We are so close. Well, no, look. We just, guys, we just need the answers between what and what?
0 and 2 pi.
Between 0 and 2 pi. X equals, my first answer is going to be, well, it can't be this one, so this has to be my first one. 3.85100, comma. My next answer, it takes this negative and add 2 pi. So scroll up, and I'm going to go that guy plus 2 pi. 5.57377. 5.57377. Done. That's it. Those are my two answers. Oh, I just noticed something. I don't know if you guys noticed. No. It's all correct. It's all correct. It's all 100% correct. Read example 4. What does example 4 not have that example 3 does have? Did I have to solve it algebraically? Look, we're going to just take the... Yeah, guys, look, we're showing you all the different ways. I'm showing you all the tricks. All right, look, here's how you type it in. Ready? 4, and then open up a parenthesis for the sine squared. You're going to go sine x, close, put a square on it. And then what was it? Minus 2 sine x? Minus 2 sine x. And then what was the last number? Was it minus 3? Yeah? Minus 3. And then it equaled what? 0? Oh, okay, so you don't even have to type anything on the y-axis. Remember, on the y2, sorry. Remember, anytime it equals 0, that means you cross the x-axis, right? And I'm clicking on window. You're only going to look between 0 and 2 pi. So 0, 2 pi. And then I'm going to look, I know what the magnitude of that is, so I'm just going to go. But if you didn't, you could have just left it as negative 10 to 10. And then check it out. Graph. I bet you these two numbers are the numbers where they crosses the x-axis. Guys, make sure you know how to use the calculator. Look, this is a calculation, right? So you go second, calculate, and then look. Is there something that says 0 there? Number 2. And that's going to tell you, where do you want me to look? That's what it says. It says left bound. I want you to look between here, and then I'm going to scroll to the right. The line stays there, and then I cross it, and then I push enter again. I want you to look between those two. It says guess. That means if there's several of them, you go to the one that's closest. There's only one, so I'm just going to push enter. Make sure it says the word 0. Did I get 3.851 as one answer? Yeah, check it out. Second, calculate number 2 again. And I'm going to push, let's see, I'm going to scroll to the right, left bound, enter. I'm going to scroll more to the right, and I'm going to push enter again. And guess, there it is, 5.57377. Cool or not cool? Okay. All right. Yes. I just pushed second, calculate, and then from all these, I want to know where I cross the x-axis, so that means it's called a 0. And then it's going to say left bound. That just means where do you want me to search? I want you to search between here. Right bound. How far do you want me to search? And here. And it's looking for a sign change. And there it is. 5.573. All right. Oh, just push enter. Left bound, right bound, and then when it says guess, push enter. We're almost done, guys. All right. We're getting easier now.
You said that was the last question.
That was the last hard question.
You said that's the last 2 questions.
All right. Inspired by Delta. Here we go. It's going to be, relax. It's not going to be that bad. Yeah, but it's not due today. It's not due till Sunday. All right, here we go. Don't mess with secant. Don't mess with Texas. Don't mess with secant. I mean, I guess you could if you feel very comfortable with it. Get secant x by itself first. So divide both sides by square root of 3. Secant x equals negative 2 over square root of 3. And then you're looking at it and you're like, what? What's the reciprocal of secant? Cosine, yeah. The reciprocal of secant is cosine. The reciprocal of cosine is secant. It goes back and forth. So turn this into cosine. Cosine x equals, and then just flip this. Yep, with the negative in the front, or you can put the negative with the 2 or the 3. And now, look, you don't even have to use any formulas. You just think. On the unit circle, so let me draw a unit circle right here. Cosine, which is the x value, is negative square root of 3 over 2 here and here. What are those angles? That's one of them. What's the other one? There you go. Good job. Usually you would have said it the other way around. The 5 pi over 6 and the 7 pi over 6, because 5 goes before 7. But it's fine. It's fine. Not a big deal. Not a big deal. Do you see how we did it, guys? Look, very little calculations. You didn't even calculate it at all. Now, if you use a calculator, you'll get the same answers. but you're being a robot. Like, you don't have to. Does that make sense? Okay. Look at this one. Look, we're going to do another one, Uncle says. That was it. That was it. See? Another one. Can you be a robot? Yes, you can. You'll get the right answer, but you don't have to. You don't have to. So on this one, it requires one more step, but it's not as hard. It's just as easy as the last one. I'm going to get rid of the cosine by doing inverse cosine. So I'm going to write 6x equals, oh, Travis told me to always write plus minus in the front. Always, always, always. But you don't have to. You don't have to. If this is perfect, which it is, on the unit circle, and I'll show you with using logic and using formulas. On the unit circle, there's two locations where cosine is 0. Where and where? Perfect. You could have, okay, so put your pencils down just for this. You could have very easily just gone 6x, don't write this down, I'm going to give you time, because I don't want you to become a robot. You could have written this, and then you could have said, okay, one of the equations is the positive one, so don't write this down, because I don't want you to be a robot. Pi over 2 plus 2 pi n. Oh, and the other equation is the negative one. Negative pi over 2 plus 2 pi n. But look, don't write this down, just listen. Negative pi over 2 plus 2 pi would have given me 3 pi over 2. Negative pi over 2 plus 2 pi, common denominator, so I'm going to change this to 4 over 2. And look, negative 1 plus 4 is 3 pi over 2. But you don't have to be a robot, because you guys know the unit circle really good, so you don't have to do any of that shenanigans. You can just go ahead and just write, like, immediately. Oh, I'm going to erase a little part of that. That's fine. You could have just said, just like what you told me right now, you could have just said, oh, okay, two answers. Pi over 2 and 3 pi over 2. Okay, and that you can write down. Did that make sense, guys? Like, you can use the formulas to get you those two equations, but you don't need to, because these is a perfect coordinate. Like, you know what's up.
Wait, but how do we get pi over 2 and 3 over 2?
This right here. That right there, arc cosine of 0 equals pi over 2, comma, 3 pi over 2, comma, 5 pi over 2, comma, 7 pi over 2, comma, 9 pi over 2. Really any, I'm going to write ... n pi over 2, where n is odd integer. That's series. We'll get to that in calculus, in Cal 2 really, when you're there. But if you're not there, don't worry about it. Say it again. Oh, yes, we do. We got to isolate x. So we're almost done. These are general equations, right? We don't have the general equations yet. We still got to divide by 6.
Oh, okay. So look at that.
Yeah. Divide by 6. Whatever you do to one side, you do to the other. X1 equals pi over 12 plus, I'm going to reduce it. Pi n over 3. Same thing with this one, guys. Divide by 6, divide by 6, divide by 6. X2 equals 3 goes into 6 twice. So pi over 4 plus pi n over 3. Here are my answers. Pi over 12. Pi over 4. I'm looking between 0 and pi over 3. Is this making sense? I don't know why I did try to do a little accent there, but yeah, fun here at okay. Okay. It'll get back too easy. You'll see. It's not bad. Almost. Guys, I'm just trying to give you guys the best. All right, here we go. I'll tell you what. I'll stop. Okay, I'll tell you what. I'll stop at example 8. No, we still got another one. I want to give you. I'll let you guys decide when we get there. Example 7. Here we go. Don't worry, guys. Don't worry. I'm trying to solve for x. We're not even going to use formulas. Look at this. I'm trying to solve for x. What's my first move? No, not yet. I got to move the 1. So I'm going to write 2 sine 3 half x equals 1. Now what's my next move? Divide by 2. Good job. Sine 3/2 x equals 1/2. Now what's my next move? Arc sine. Check it out. Don't worry, I'm going to slow down. Arc sine of half plus 2 pi n. And I'm going to come over here and I'm going to write arc sine of a half equals, so think about the unit circle. There's two answers. Where is sine equal to a half? And give it to me in radians. Pi over 6, what's another one? Quadrant 2. There it is. See, we didn't even use formulas. So here it is. I'm going to do equation number 1 right here. 3/2 x subscript 1, or x of 1, equals pi over 6 plus 2 pi n. I'm trying to solve for x1. I'm going to multiply by the reciprocal, whatever's in front of this. It's like the same thing as dividing by 3/2. So I'm going to multiply by 2/3. Whatever you do to 1, you do to the other. So now I'm going to have x1 equals, okay, and I'm going to time out right here real quick. I don't remember who it was. I don't know if it was one of you guys, but you guys were here after school and you asked the question, Chav, I don't understand like how you're getting these things so fast. I'm literally just multiplying like this. Now here's what I prefer to do. In my head, I go pi over 6 times 2 over 3, and I do this. I see a 2 in the top, I see a 6 in the bottom. So I say 2 goes into 6 3 times. And then 3 times 3 is 9, so I say pi over 9. And then when I come over here, I'm gonna write pi over 9. That's how I do it. But this kid that was here after school, which might have been one of you guys, I can't remember who it was. It was you? Okay. So I did this. So yeah, see, I couldn't remember, miss. Pi over 6 times 2 over 3. And you like this better. 2 pi over 6 times 3 is 18. And then 2 goes into 18 9 times. It's the same. It does not matter, but I'm just trying to let you know, like that's what I'm doing in my head. See, I didn't remember who it was. I'm sorry, but nothing but love, miss. All right, plus 2 pi n times 2/3. 2 pi times 2, that's 4 pi. So 4 pi n over 3. That's actually the period of this function. No big deal. All right. Remember, there's two equations. I'm going to rewrite this. I'm going to write it in purple. 3/2 x2 equals, you told me the other answer was 5 pi over 6. 5 pi over 6 plus 2 pi n. I'm going to multiply by 2/3 again, just like I did to the other one. 2/3. And here we go. x2 equals, 2 goes into 6 3 times. 3 times 3 is 9. So I'm going to write it as 5 pi over 9 plus 4 pi n over 3. We're okay? I'm going to continue in purple, the purple light. Actually, no, we're done. Here are my answers. X equals, I'm looking between 0 and 4/3 pi. So one answer is pi over 9, comma, the next answer is, there you go, 5 pi over 9. You cannot add, oh, sorry, I pushed a button down here. You cannot add 4/3 pi because that would take me outside the domain. Do you see what we're doing? Okay. All right. Last problem here, and then we'll call it a day. Yeah. All right. Here we go. So I want all my answers between -6 and 6. I know, guys. I know. First move. I'm going to move what? So 2 sine pi over 6x equals negative square root of 3. What's my next move? Divide by 2. Sine pi over 6x equals negative square root of 3 over 2. Okay, one more. What's my next move after this? Arc sine. Pi over 6x equals arc sine of negative square root of 3 over 2 plus 2 pi n. All right, on the unit circle, this is why we emphasize it so much. Where is sine negative square root of 3 over 2? It happens. No, that's cosine. Where is sine negative square root of 3 over 2? It's in quadrant 3 and quadrant 4. Something over 3. 4 pi over 3, and so there it is. So I'm going to write pi over 6x equals, the first one is 4 pi over 3, plus 2 pi n. And I guess I'll write the other one on the other side since we're at it already. Pi over 6x2 equals 5 pi over 3 plus 2 pi n. Are we still okay? I'm looking at the red one, not the blue one. I want to get rid of that pi over 6, so I'm going to multiply it by 6 over pi. Whatever you do to one side, you do to the other. Here's what I get. x1 equals, let's see, 3 goes into 6 twice. Pi's cancel out. 2 times 4 is 8. Get a nice, pretty number. See? All I did was this. You can go 4 times 6, 24. 24 divided by 3, 8. All right, the next one, the blue one. I'm going to multiply this one by, again, 6 over pi. Whatever I do to one side, I do to the other. And here's what you're going to get. x2 equals, 3 goes into 6 twice. 2 times 5 is 10. The pi's cancel out, plus 12n. Okay, yeah, look at the domain. Is 8 within that domain? Is 10 within that domain? But there is answers. Instead of adding 12, I could always subtract 12, because that's the period. What's 8 minus 12? Negative 4. Is negative 4 between negative 6 and 6? That's an answer. So I'm going to write it here so you guys can know how I did it. 8 minus 12, negative 4. Yep. 10 minus 12, negative 2. So those are my two answers right there. Do you see how we did it, guys? All right, we're going to set you guys loose. I might give an extension on the delta, so check on Saturday night. But I do want you to at least attempt it sometime today, guys. Maybe during advisory, or make sure you at least have some experience. That way you can ask me questions. Does that make sense? Okay, so I expect to hear from you guys, and we'll call it a day.